How much does a Pug Mill cost? Are you kidding me? So why do you need a Pug Mill? I wrote down a couple thoughts. Let me run through them with you. Nearly every potter that I know or I talk to does not have a Pug Mill in their home studio. And the number one reason why they say is, hey, I don't have enough wheel scrap and trimming to be worth recycling. It would take me 1,000 years to justify many thousands of dollars on a Pug Mill purchase. But in my mind, there are other things that it does. In my case, it's not just wheel scrap and trimming, but also the amount of failures that I have in terms of making pieces. They air dry, they crack, I drop them. All sorts of waste related to air dried clay failures. But even this one is not very important. In the big picture, whether you're paying 40, 50, 60 cents a pound for wet clay, it might be hard to justify these two in terms of total purchase price. To me, one of the biggest ones is slab rolling. I'll roll a big slab, I'll use a cookie cutter, I'll cut out a bunch of things, and I'll have all this extra waste, and it's a shame to let it dry, and I'm just not in the mood to spend hours of time. That's also true of the extruder scrap. Both, you'll extrude a piece and you'll cut off the ends. Using the extruder, you end up with a lot of extra scrap when you clean the barrel of the extruder. So, and probably least mentioned by anybody, but it just seems so obvious to me. If you buy a lot of clay, you know that you can buy a bag of clay and you get it out and it's a little bit stiff. That's the worst. I mean, it's very difficult for the home potter to add moisture back into their clay. Probably the quickest way would be to take your slightly stiff clay, cut it up, completely air dry it, slake it down in a bucket with water, flip it out on plaster, and then you're still going to have to wedge that clay, knead that clay, and hope that you can get all the air bubbles out. No way. I want to know that when I have clay I don't like, I can just throw it in a machine, run it for a few minutes, and it comes out soft and warm and air-free. That is a huge value. And this one right here, the conditioning of fresh clay, is so important to me that it really changes the equation of how I look at a Pug Mill. I don't look at my dishwasher and say, how much money are you making me? I look at a dishwasher and realize, how much time are you saving me? So that is an underestimated upside of a Pug Mill. And as well, if you've ever looked for a used Pug Mill, you realize these things have insane resale. So it doesn't really matter what the purchase price is, it just matters what you can sell it for when you're done. And the gap between those two numbers, I think, easily covers this if you're doing a fair amount of clay through your studio. So that's my thoughts on why. So I mentioned I don't have a plan throughout this video, but I want to point out that I have been thinking about this project for years, and I bought a couple books. I bought this one first, Building Pottery Equipment. It seemed like a promising answer. But you get to clay mixing, and they're showing like hanging a barrel from like a tree or something. It just seemed ridiculous to me. Now, this book, The Potter's Alternative by Harry Davis, much more helpful. Very detailed Pug Mill build. Now, this is not a mixing Pug Mill. This is just a straight Pug Mill, so it only runs in one direction. It has some screens that break it up. You can add a vacuum to this design, but if you see here, I've been looking at this for so long thinking, my God, the idea of having to make all of these pieces, and like all of these tubes are not pipe fittings. These are flat pieces of steel that you cut out in some manual way and roll and weld on the flanges. I mean, this is no joke, and I'm not even sure I like this design. My process is really one of kind of laying out the whole thing. I'll just sketch some shape, and okay, I want a gearbox and a motor and some sort of foot and maybe like a feeding tube, and I just kind of sketch out these concepts with no measurements. I don't need the measurements, because the moment I understand how this all might go together, I'll jump online and I'll start looking at motors, or I'll start looking at pieces to see, you know, what I need to make this plan happen. And then I order the most important thing first. And once I get that thing, I can take measurements off of it and start thinking about how to make the next thing fit. So that's how I'm going to go about doing it. So I do think it's worth mentioning that I have zero professional experience and zero professional training in any of these things. All of the equipment that I own was bought off of Craigslist, sight unseen. I'd never seen a lathe or a mill before I had gone and purchased one myself. I'm completely YouTube trained, just hours of videos and personal interest. My background is in accounting and in public education, so take it for what it is. So in this project, I wanted to start by identifying the motor and the speed control first, and then we move on to transmission, gearbox, and then the mixing chamber. So I'm going to use the same speed control that I used in my homemade pottery wheel. This motor is a 1-horse motor, so the wiring and the buttons to make it all run will be one of the last things to do. But so rather than do a gearbox with shafts and chains and gears, you need to slow this thing way down. My target RPM is probably in the mid 30 range on this end, but I don't know for sure, and so this is a speed controllable motor, so I will be able to vary the speed. So I've opted for a 40-to-1 gear reduction box, and it just bolts right up like that. So it'll get bolted on, this foot will be removed, and that will just kind of hang there. It definitely costs a little more money. I actually bought these two at the same time from Automation Direct, and the cost for both was $700, so it was like $480 and $220, I think, were the prices on these. But yeah, $700. You're up to about $900 with the speed control, and that gets half of the Pug Mill easily done and out of the way, and we can concentrate on the mixing chamber. All of the components here forward are going to be stainless steel, and I've opted for 316 alloy steel. 304 is pretty common too. 316 just looks a little brighter and welds a little easier. So I have this rod here, same size, and then all we're going to need is a coupler. So I have this whopper. It's a little over 2 inches on the outside, and it will go on here like this. And I'll use the mill and I'll put a keyway in, and we'll set a key on here. And I don't have plans, right? I'm just doing this. We're going to build it one bit at a time. We're going to make the next thing fit. And so I want the mixing chamber built before I decide on the final lengths for this. Because I don't want this machine to be really, really big, really, really long, I'd like it to be as short as possible. I don't like the fact that I'm losing all of this distance before I can put a bearing like this, you know, to support it. So I've opted to get a 2-inch pillow block, and what that means is that I'm going to put this in a lathe, and I'm going to cut this down to exactly 2 inches. I have a pair of grub screws here, and this will fit right in between, so I can still have access to lock the keys on this. But we're going to turn this down, and we're going to put this bearing on the back side here, and that will hold the back of our mixing shaft. So this, to me, is the exciting part. This is the hard part of the build. I've been thinking about this for years, and I just have not come up with a clean way to build a mixing chamber out of stainless steel without just a tremendous amount of fabrication. And I just don't want to deal with it. So what you're looking at is 316 alloy stainless steel Schedule 40 pipe fittings, and they're for butt welding, they call them. And so they just have a bevel grind here so that they can be welded together. But these things are heavy. Oh goodness. But it's an 8-inch T-fitting with a 6-inch opening for throwing the clay in. And then these flange fittings, this is how we'll take the chamber apart. Now you might be thinking to yourself, holy smokes, Justin, those look really way too big. Are you kidding me? I'm not kidding you, and they are way too big. It's one of those things, I looked at the measurements, I knew they were heavy, but boy, it wasn't until I got them in my hands that I realized just how much overkill it probably was. It'll go together like this. So this will be the back chamber wall, and then this will all be connected and we'll unbolt, and this will all come apart for cleaning. And this here will be welded. Now, and I could TIG weld this with my welder, but I'll be honest, I care about this project a little too much. These 4 pieces, if you're wondering about cost, they are expensive. Grand total, you're looking at just about $1,200 worth of pieces. For these 4 pieces, $1,150, something like that. Pretty freaking expensive. Oh, and by the way, if you're wondering, geez, I'd hate to ever clean that thing. How are you going to lift? I mean, this plus this has got to weigh 80 pounds, maybe more. I mean, it would be a real bear to lift off in one piece. So in the end, we're going to build the whole thing, but I'm going to be adding a little kind of a leg up here and a pair down here with little wheels. They may or may not have a track, but when it's unbolted, you should be able to just roll this away on your counter, get it out of the way, and you shouldn't even have to lift it. That's the idea. So, but before I have any welding done by a local shop, hopefully we'll find one that's open, there's a couple things I need to do. Now, because while these are apart, I can put this cone on my metal lathe and I can change this. I have one opportunity to decide what the snout should look like. You know, I need to think about having attachments. So I'm inclined actually just to give myself a machined flat surface, maybe an inch in, and about halfway in the middle of that I might put a groove, just so if I have a rubber boot, it'll kind of snap into a ring, and B, if I ever want to put like a tile extruder or some sort of extruder die on it, it just might be nice to have a groove there so I can have some set screws or something to. I did want to point out that I did get a couple other little odds and end metal. I got a pair of these. I want to say it's 3/8 by 1.25 inch, 3/16 stainless. I got 2 of them, 2 feet long, and I'm going to use that to weld it onto the body of this, and have this will be the mechanism for pushing the clay in the top. And then I did get some stainless steel sheets. So this is 0.105 stainless steel. That's the thickness of it if you're curious. And this will be a stainless steel table that I'll put on top of the machine over the motor and gearbox, give me a place to set my clay. And then I have a more substantial stainless steel plate. This is 0.1875 thick. And so this is what I'm going to do some layouts and just take a grinder and come in. I'm going to cut out all the fins and auger blades and maybe some parts for the clay pusher too. But this plate was bought to cut the auger blades out, and then we'll grind them, clean them, and weld them to the auger shaft. So that's the plan. Okay, so I have the nose cone set up here on a chuck. We can see the jaws are on the inside, and I have copper pieces there just to make sure I don't mark it up too much. Well, I think that looks pretty good. Okay, so the next thing I need to get done is I need to turn this down on the lathe so it fits inside. I just need to clean this really good because it's steel, it's not stainless. I'm going to get some black paint on here to keep it from rusting. And we're on to the next part. I wanted to show you what I've done. I've got the rotary table set up and I have my little wiggler, and I've gone ahead and touched off on the center of this hole and did a bunch of measurements to make sure that in fact I'm dead center right in the middle, which I am. And then I have the digital readout set to, that's 10 thousandths, so basically 0. And next step is to get the plate up here and to take some measurements and get the plate centered right on the center of the rotary table so we can have confidence that we're concentric. 2 bolts that go through the holes to kind of hold it down. And I've gone around and I've taken some really accurate measurements to make sure that this is fully concentric to the table the best I can. I did have to jump onto McMaster-Carr, pull the dimensions on the O-ring that I bought. 4.875 is the radius I want for this 1/4 inch bit. So I've gone ahead and moved it over 4.875, and that is where the groove is going to go. I think I got the groove just exactly where I want it. Have it all cleaned up. Let's make sure this is going to fit. Oh yeah, yep, there you go. Now all I need to do is come back to my 0. I need to flip this over to put some holes on the other side, but first thing I'll do is get a center drill right in the middle, drilled all the way through, so that way when I flip it, I can just use that as an alignment to recenter it. So for the next step, I want to enlarge this hole to a little bigger than 1.25 inches. So I have a boring bar here, and I use this dial to adjust how far this sticks out to make this hole bigger. So I'm going to go down and take several passes and we'll move it over and go down. But let me turn it on, you get an idea of what this is actually doing here. have the whole board to the right size, and so I put a drill bit back in, and now I need to put the 4 holes in, and I'll just use the digital readout and drive around to the 4 numbers that I'm going to need and get these. We're going to use a small drill bit, and then we're going to use a bigger one, and then we'll put some threads in those holes. Rather than stopping while I'm at each corner and running through all of the drill bits, I wanted to peck out all 4 holes, and I'm going to just do a reality check with the bearing and make sure everything looks right, and then we'll come back, find those holes again, and open them up. So this is what we're going to use for the frame. I just got it from the steel yard. It's a 20-foot piece. I had them cut it in half so it fit in the truck a little easier. But it's 2 inches by 2 inches and a 1/4 inch thick. So this stuff is heavy. But you know, on a project like this, weight is our friend. And this hole, the 20 feet, was something like $4 a foot. So wasn't terribly expensive, but I'm gonna wipe this down and we're gonna carry it in and start chopping it into pieces and figuring out how this frame is gonna go together. So here's where I am. I've gotten the main rails cut, and I cut out 4 pieces for this kind of backer plate here, and I'm just using plywood right now to kind of set the height. I need to build a piece here that goes up and over and holds this just at the right height, but I can't do that until I finish tapping these holes, which I'm going to do next week. I need to get a new tap set that can get me the right threads into that hole. We'll get that bearing set, and once that bearing is set, I can start kind of tacking this whole frame together and figuring out, making sure everything is square. But I think it's looking pretty good. Made a jig here, because I found a local welder who can weld this up for me, and so I made this kind of alignment jig so that he can look down and, you know, adjust this to make sure that that is square, which it's not right now. But anyways, so that's going out this week for welding, and we'll come back once these pieces are welded up and we can get this frame put together and make some progress. So for the first operation, I use a taper tap, and then I use a bottom tap to get the threads to go all the way down to the bottom of the hole. Well, the pieces are back from the welder, and boy, I am really happy with how this turned out. I'll give you a close-up here in a second, but let me tell you, there's no way that I could have done this quality of work, and they charged me $200 to do this. Now when I picked it up, they said they actually really underestimated how much fill, I'll show you on the other side, it took, and if we did this again it would have to be at least $300, but that'll give you a range, $200 to $300 to have this welded up. And even if you're a reasonable welder, you know, there's no practice material and this stuff is expensive. So look how nice and clean that is. So nice. So even. Let me flip it over and I'll show you the bottom. This is what the welder got back to me on and said, You know, there was a big bevel on this pipe, and there was a pretty good sized gap, and so it took something like 12 passes on this one seam, and you can tell by the color they certainly put a lot of heat into it, but it looks really good. If I did it again, I would take this and I'd cut back that bevel quite a bit so there wasn't such the gap to fill, but whatever. That looks better than what I could have done for sure. And at $200, I think it was a bargain.